So like you guys, most of us voted, you said it is B. Now, who can tell me how they know it's B? Like A looks like it's 50 cents per ounce. 50 cent, right? Up 1 over 2, up 1 over 2. Why B, Connor?
Well, it can't be C. It's obviously
Why not? C is $4. It's $4.
Yeah, but and it would be B because there's like a drop off.
There's a drop off on B?
Like not like dude, I don't know.
Let me know what you're saying. Yeah, I'm just asking for
Yeah.
clarification. I'm not saying you're wrong.
Yeah.
No. What do you mean by drop off?
Like
It becomes constant.
yeah, constant. Yeah.
Well, it's constant right here. Constant rate of change.
Constant descent.
Oh, it has an output that's the same for a while?
Yeah.
Okay. Yeah, so
Yeah, that's what I meant.
right here, this is 50 cents per ounce. Correct?
Yeah.
And then once you get to 8 ounces, how much is it from 8 to 12?
Yeah, that's
It's just an output of 4. So what we're going to do, this is a piecewise function. Means there's pieces to it. And what we're going to practice today, don't freak out if you don't understand this. You'll probably understand it as I write it. Don't freak out yet if you're like, I don't think I could write that. What we're going to do is we've got a price per ounce. And to write this function, I can't just write one thing, right? It's not like 50 cents per ounce forever. So we use a bracket. And what we would say is it's 50 cents per ounce. I'm going to want more room than this, but from what's the lowest number of ounces that works for that? 0 all the way up to 8. So this little inequality, Z needs to be greater than or equal to 0, less than or equal to 8. That's saying from 0 to 8, so input 0 to input 8, it's 50 cents per ounce. Then, from its output of 4, from 8 all the way up to 12. So 8 to 12, output 4.
Why did you use the equal sign?
Well, you don't have to or equals on the 8, because guess what? 50 cents per ounce times 8 ounces is $4. 8's $4. So that one, it's just the same point. But we will define that a little more on some of the next examples. You'll see. All right? This one's just a little warm-up. Here's what we're going to work on now. You're going to start by only working on problem 1 and 2. This is about stamps. You guys know you have to pay money to mail things? And a lot of times when you mail things, it's dependent on the weight. So there is a function in the top right corner, up here, okay? That's the function up there. And your job is to use that function to say the price for 1 ounce, 1.1 ounce, and a 0.9 ounce letter. I also then want you to tell me the weight of a 92 cent letter. Don't worry about 3 yet. We're going to work on 1 and 2. So again, it's about postage stamps and how much the weight costs. You need to find the cost for those 3 weights in 1, and then tell me the weight for the cost in 2. So again, you're going to get inputs, give me outputs, and then you're going to get an output, give me input with your group. Let's go. You're going to use the tape. You're going to use the graph. Oh, it's closed. Please, 1 ounce. How much is that going to run us? What do you guys think? 50 cents. Here's why. 1 goes in, 50 cents comes out. How about 1.1 ounces? Just a little more.
74 ounces.
It's like right there. Right? Is everybody seeing that? It's just a little more. That's actually going to be 71 cents. I just used context from down here to help me out. Okay, and then 0.9, so just a little less than 1. How much is that one? 50 cents. All right. So the interesting spot to make note is 1, because it goes through this dot and then it goes through that open dot. What do you think the open dot means?
It's not equal to 9.
Not an answer. Correct. Okay, so if it costs 92 cents, how much must it have weighed?
2.5.
Well, I'm going to come up here. This chunk right here. Is everybody seeing that chunk is 92 cents? Okay, so that's going to be output in dollars. So I'm going to just say the number of dollars. What's the lowest? It needs to be more than what?
2.1.
So it needs to be more than 2. So I'm going to write it like this. It has to be more than 2. That includes every little thing. Okay, but and what's the most it can be? 3. So check this out. This says 3 does work. This says 2 doesn't work. 2.00001, does that work? Yes. 2? No, that's why there's the open dot. So we're gonna keep working on using these inequalities to explain all that, because there's infinite answers, right? All those weights. Okay, what you're gonna do next is down here we have Kieran and May, and they wrote remember how on the warm-up I showed like the rule, the way you write the rule? So let me show you kind of like how to read this since it's newish. This is the function K of W. So the weight goes in, the cost comes out. This is saying we get an output of 50 cents, so that'd be this chunk right here, when W is 0, but not when it's 1, but everything in between. Okay? So do you see how to read it? Then output 7.1, we'd be looking at this chunk. Output 0.92, we'd be looking at this chunk. Output 1.13, we'd be looking at this chunk. Everybody see what the reference is? So there's an issue with both of their rules. I want you to try to find the mistake with their rules and fix it. Who can tell me what Kieran did wrong? You got Bella?
So for 0, 1, 2, and 3, those don't work.
Yeah, so you're saying right here, open circle shouldn't work. She says 0 should work. So this whole row right here on the low end should just be what? Yeah, it's a less than symbol, but yeah, W should be greater than those values. Those open circles don't work. This says that these do work. Okay? So what did May do? Daniel?
She says that 3.5, 3, and 1 don't work.
Yeah, and these high ends, right? 1, right there, they all should work, right? So these need to be or equal to. Everybody seeing the difference between the solid and the open? Do you guys make a connection? Remember when we did inequalities on a number line? Same thing. Open circle means it didn't work. Closed circle means it does work. Okay. So that's it for stamps. I think we're feeling good with stamps. Now we're going to talk about bike share. I don't know if anybody in here's done the bike share. In Grand Rapids, where they got line bikes and they got scooters too, especially if you head toward downtown. Maybe by Harmony, there's some on the sidewalk. Okay. I did it in San Antonio, and these are I think these were really the prices when I did it in San Antonio. We rode bikes around all day. Electric assist bikes, so you didn't even get tired. But here are the prices, $2.50, $5, and so on. And then the rule gives you the inequality for the piecewise function of how you're getting those prices by time. Your job is to complete the table. Number 1. Number 2, describe in words what's happening here. Number 3, determine the domain and range. And then it's not numbered in number 4, but then 4, you're going to sketch the graph. I'm going to hand out graph paper. You can choose to do this all on your graph paper. Some people did some of it on the graph paper. Some people chose to do it all in their math notebook. I'm just going to give everybody a piece of graph paper so you have the option for the graph to use graph paper. All right, this probably looking about 10 minutes for this, guys. It's going to take a little time. So I know some of us are still working. We're not going to run through the whole thing. We're just going to work on the table. So check this out. 0 minutes. Can time be 0 minutes? Has to be greater than 0 minutes. So no answer. There's no answer to this function for that 0 minutes. Are you seeing how I got that right here?
Yeah.
This says time has to be greater than 0 minutes. Okay, 10 minutes falls in this interval, correct? So 10 minutes cost how much?
$2.5.
$2.50. Okay, 25 minutes.
$2.50.
That interval, $2.50. Okay, 60. So notice there's 60 twice, so we have to decide which one. This one says it can equal 60. This one says it has to be more than 60. So we have to go with equals 60. So that one is 5. And you need it. Could you have 2 different prices for the same time? No, that'd be really confusing to the consumer. Like, how much am I paying? Well, here it's clear. 75 minutes, we're going to fall in this interval. $7.50. 130 minutes, we're falling in this interval. $12.50. 180 minutes, we're falling in this interval. $15. Okay, so what you're going to work on next is 2. Well, maybe you're already working on it. I'm going to give us more time. You'll describe the rule of this pricing model in words first. Okay, just what's up with the prices? How do we know what the price is? Words. Like if you're the person trying to talk people into taking these bikes out, how would you explain the pricing model to them in words? Then you're going to work on the domain and range of the function and sketch the graph. Should the graph look like this? No, because is it all prices or like in chunks? It's in chunks, so be mindful of your graph, all right? Let's get these words down. I'm trying to buy these bikes. Who could describe to me the rules for purchasing the bikes? Who thinks you're trying to sell it? What's it going to cost me, Trip? So I'm going to write it in this area, even though I know this is under 3. That's fine.
If you spend 0 to 30 minutes on the bike, it's going to cost you $250.
So you're gonna so it's going to cost me $250 for every 30 minutes, right? Look at. So let's write that down. Trip says $250 for every 30 minutes. Until when?
No, till you get
Until over 150 minutes.
Oh.
Once I get over 150 minutes, all the way up to 720, which is $15 for up to 720 minutes. So the way we'd explain this is, you're going to rent these bikes from us. It's $250 for every 30 minutes, up to 150 minutes. Once you have passed 150 minutes, it's only $15 total for the rest of the day, up to 720 minutes. Are you guys seeing that gap right here? So it's going by $250 every 30 minutes. It must be. Yep, 12 hours. Okay? Everybody go with this rule for 2? $250 every 30 minutes. Until you get more than 150 minutes and it's $15 for the rest of the day, up to 12 hours. So that's how you could say it with words. This is how you would say the function with the rule. Let's work on the domain and range. I'm going to write them. Let me make a little space. I'll make a little space up here. Sorry, bikes. So the domain is all possible inputs. Schulte, what kind of times could we ride bikes for? We talked about this. What kind of times? Inputs. What kind of times could we ride these bikes for? How long? We talked about this. That's why I called on you. What's the most minutes? So I see 180 in here somewhere. But what's the most that works? 720. So actually, see how this says time has to be more than 0? So I'm going to say time has to be more than 0. Okay? And at most, we can ride for 720. That's the domain for this function. This says we're going to ride up to 720 minutes. Everybody go domain? That's all the possible inputs. Now the outputs, what's the lowest amount of money that we can spend?
$250.
Here's the outputs. Yep, $250. And it's called, this would be C of T. And we can spend $250, right? What's the most we could spend? 15. But are we spending all the values in between?
Yes.
No. How could I explain these numbers? What's happening?
It's just $250.
Yeah, so we have to say multiples of 250. Right? Because it's not all the pennies and everything in between. It's every $2.50.
Sir.
Everybody follow those things?
Sir.
So the times we could ride, all the way up to 720 minutes. All the way through 720 minutes. The prices we would pay would be somewhere between $250 and $15, but only multiples of 250, meaning 250, 5, 750, 10, so on. Okay? Let's graph this thing. This is the fun part. So I'm going to go down here. 250 is my first output. Does 0 work? No, but it's my reference point. So I'm going to go open right here. And it's $2.50 all the way through how many minutes? 30, which means I'm going to put a dot at 30. 30 does work. I know 30 works because right there, or equal to. So next output's 5. Does 60 work for 5? Sorry, does 30 work for 5?
Yeah.
No, the time has to be more than that. So I'm open at 5 because it's my reference point. And it's that price all the way through 60 minutes. At 60 minutes, after 60 minutes, output is 750, but 750 doesn't work. It does work all the way through 90 minutes. 90 minutes doesn't work for $10, so I'm open. But it does work for everything through 120 minutes. 120 minutes does not work for $12.50, open. But it does work everything through 150 minutes. 150 doesn't work for $15, but actually everything is $15 until 720 minutes. I ran out of graphs, so I just did the arrow over to 720 minutes. So this is a function. You got the toughest points to look at, I think, are like where they overlap, like right here. And this just tells you at 60 minutes, it has to be $5, not $7.50. And again, that's important for the business because you shouldn't have two different prices for the same amount of time. That would be confusing to you and your customers. All right. There's a lot going on this page. Think about this. Anybody ever ride one of those Lime bikes in Grand? I've never ridden one downtown. Pretty cool. Yeah, I did the San Antonio ones, more than 20 miles in one day.
Oh, I have.
But it was electric assist, so it's kind of cheating.
What?
So this is the thing. You might get something wrong, but it's cool. We're going to do output is the cost of age, okay? You're going to use these rules, and you can use this. You're going to write the rules. How many different chunks, how many different rules are you going to need? 3 rules, all right? Do your best, get it wrong. Take 2-3 minutes, but you got to do it. You can't just sit there and wait for me. It doesn't work to learn as well. So get down your 3 rules, and then we'll check it. Little thing I'm going to change is, see right here it says free for children under 5. It had open. I think 0 should be free still. It had to open, like not an option for a 0-year-old. But that's kind of what you call a kid. I don't know. If you're going by years, it's 0 years until they're 1 year old. Usually people use months. So I put a solid dot there. I kind of changed it. A. This is just saying cost is a function of age. Cost is a function of age. If you didn't do anything, you're only cheating yourself. The lowest price is $0. How do we get $0? What ages? Age of 0 works. But does 5 work? No. So right here, this says it's free for ages under 5. The next, what's the next output? 5. And it costs $5 for what ages? Does 5 work? Yeah, 5 works. And does 11 work? 11 doesn't work, so just less than. So what this says is it's $5 for everybody that's 5 up to 11. Okay, what's the last output for these children?
11 to 16.
$7 is the output. It's if you're 11, it works. So less than or equal to, A is greater than or equal to 11. 11 works. Does 16 work? No, so it has to be under 16. So this is my function rule for this train. It's listed, again, listed output. It costs $0 if the age is 0 up to 5. It's $5 for ages 5 up to 11. It's $7 for ages 11 up to 16. These do not say or equal to because these ages don't work for these prices.
Oh, it doesn't work because it's an open circle.
Open circle, yeah.